Today we're going to do an example involving probability and a particular conditional probability. Let's see. The example is sent to me by one of the students for Chapter 5, Probability Distributions and Data M. I'm not sure. So it's Chapter 5, number 7. So I already opened it up. Sorry, let's go back. Apologize for this slow start. View, share content, the whole thing. Okay. So, as I was saying, this is the example. There was the example a moment ago. There it is. So we have data. And I would recommend doing this in StatCrunch. I'll show you in a second. Again, of course, it could be done in Excel. Here's the data. Let's see this. Open StatCrunch. And right away we have a problem, which I wrote to the publisher. I think it's a mistake. This should have been called, the first row should be called, and the var1 should be a vehicle. Let's change it to vehicle. Of course, if you don't do that, the computer thinks that's vehicle. And try it first time. Vehicle. Let's call this gender. Okay, and that means the first row really should be deleted. It doesn't really contain data. Go to stat, tables. This is called a contingency table. We want to see how one categorical variable affects another. We have the raw data, except we have to, we'll need these three outputs, row percent, column percent of total. Oh, sorry. We also have to make the vehicles the first variable, gent is the second variable, and now we hit compute. That's all our calculations. And we have here the probability responsive is female. Well, there are a total of 29 out of 50 females. That's 58%. So I put down 0.58. And check the answer. Okay, let's get rid of that. The probability respondent drives an SUV. We'll see how many SUVs are there. There are 13 out of 50, or 26% SUVs, 0.26. Okay. The probability of a respondent is male and drives. It's called a joint probability. And male SUV. Well, male SUVs is in this column, and it's 8 out of 50, or 16%. So the numbers are there if you know where to find them. Check answer. No, what did I do wrong? Male and drives a minivan. Sorry, I'm not reading it correctly. It's too late at night. Male minivan. So it's 1 out of 50, or 2%. I'm going to give you a few choices, a few chances. 0.02. That's right. Okay. The probability of female drives either a truck or an SUV. So again, let's look at examine it closely. female drives a truck or yes, so we're dealing with females. So there are 5 females who drive SUVs, 5 females who drive trucks. It's 6 out of 50 or 12%. There you have to add together the 2% and the 10%, or do it in your head, like I just did. Okay, now comes, it is known that an individual drives a car. Probability individual is female. So this is an example of what's called conditional probability. And again, I have to advertise my videos that describe this in some detail. But again, we don't need too much theory or formulas to calculate it. There is a formula, but we want somebody who is, we know person drives a car. So got to be among these people, these 22 people. So among these 22 people only, how many is a female? Well, 15 out of 22, which is 68%, so 0.68. It is known the individual is male. So again, another conditional probability. Now we know the person's in the male column. What's the chance they drive? They also drive an SUV. So definitely among these 21 males, how many? So 8 out of 21. 8 out of 21 is 0.381. And finally, this is again involves some, again, a video explains this very nicely. And welcome to look at the video on probability. Gender and vehicle driven are not statistically independent because the conditional probability, SUV given male, which is this one, the way you write this down, is probability that he drives an SUV given or is known that he's a male. This is the symbolic way of saying it. Is not the same as the chance that somebody simply drives an SUV. The chance that somebody drives an SUV is up here, 0.26. So this number here, 381, if that equals a 0.26, is different. If the random variable, if they weren't independent, that means whatever applies to one applies to the other. So you would, doing an advertising campaign, you would treat them both the same. It's not like there's a propensity of one or the other. They're both the same. If they were independent, they're not independent. That we just proved a second ago. Check answer, and we're done. Okay, so let's stop sharing. Let's close this down.